All right, we're recording, so we shall start. It's not showing on the right screen. Give me 1 second. Okay. Can you see the slides now?
Yeah.
Yep, carry on.
All right, great. Well, welcome everybody to our first ever ColdFusion Containers Roadshow. So we're very, very excited for this roadshow today. So what is our roadshow? Well, this is part of our Ortus University initiative. It's a free month-long extravaganza. We'll have several blog posts, around 2 to 3 a week, surrounding our topics, which are containers, and more containers, led by the Ortus team and community leaders. We will have 5 free webinars every Friday of the month of September, and all sessions will be recorded. You can see the link below, ortussolutions.com/events/Container Roadshow 2017. And that's where we're going to be posting all the slides, all the videos, all the blog posts, everything consolidated in that page. So why Roadshow? Well, we want to obviously give away a lot of training for Ortus University for our community. We need to catch up as a community in terms of containers and new tooling and modern ColdFusion development. We want to demystify the container technology for the CFML community so you can actually run, code, and deploy with Docker today. So we'll be showcasing all the different tools that we've been working on, all the different techniques, a lot of tooling, not only box stuff, but a lot of tools surrounding the container community so you can actually develop through containers. We are professional open source, so you can check out our Ortus University training page at ortussolutions.com/learn. So you can actually find out all the different training availabilities that we have, not only in conferences around the world like CF Summit in Munich and CF Camp, in Munich, and CF Summit in Las Vegas this November. Our support, architecture, infrastructure, code reviews, application development, and of course, you can become a Patreon and help us support doing all this type of free training for you guys at patreon.com/ortussolutions. So thank you for helping out. Checking out the schedule for the webinars starting today. My old friend, amigo, Mr. Mark Drew, will be presenting today. He's an amazing presenter, has his own company called Command, which is amazing as well. And he will be doing our intro to containers. So very excited to see his presentation once again. Then next week, I will be presenting on how to containerize Content Box CMS, showcase you how to actually deliver a distributed CMS environment very easily with Docker. Then we'll move off into configuring your containers and make them portable through Command Box and CFconfig with Brad Wood. Then on the 22nd, we'll have Mr. John Clausen talking about Box microservices, and this will be dealing how to actually migrate your big elephants or your legacy applications and start chopping them up into microservices. And then at the end, we'll have a fun and playing session with Gavin and Docker. So a great month of great webinars. So with that said, I want to give it away to my friend Mark Drew so he can take it on with the show. So I'm going to mute myself. I stopped sharing, and it's all you, Mark.
Thank you. Let me just get it all set up here. And press play. Hopefully you can all see a little whale.
Big whale.
A big whale. Awesome. Well, welcome. Thank you very much. We'll be talking about getting started with Docker. This is kind of like an introduction to what it is and kind of why it is. So then you can actually go and expand and deploy your multi-tiered applications in one command later on. Talking of command, I work for a company called Command. We are a web consultancy, and we have clients all over the world. We're based over here in Greenwich, London, where the mean time comes from. So we make the actual time. We have a background in various technologies, ColdFusion, CFML, Lucy, doing deployments. We help development teams generally, but we help anyone that wants our help, obviously. Also Node.js and Java. We provide consultancy and developer support, basically a lead developer on call. So if you have a problem that no one can help you, just give us a call. And this is how we get exposed to these kind of technologies. So let's start talking about Docker, but really this talk is about delivering solutions, servers and applications, and servers within servers, essentially, across servers. So basically this is ship within a ship on a ship. You get the idea. But let's start talking about like our servers, the servers that we all know. We like them. Let's talk about monoliths. We love our servers. We named them lovely things like Pluto, HAL, VM112 dot whatever. We have to run to them to take care of them every Tuesday when the client calls and tells us it's down, and that's because it's update Tuesday and Windows has decided to do a patch all of a sudden in the middle of the afternoon. These kind of servers seem to be handcrafted. You put a lot of hours into getting it running, and they're basically artisanal, locally produced pieces of organic beauty. But this is not really the way we should be going, you know, because then they start spreading, and we have more servers than we know what to do with. We have different bits of code in each one because we're trying to provide solutions. They'll have different configurations. Then we have our load balancers in front of that. Then we have a web cluster that, does anyone remember cluster cats? That was a beautiful way of spending a lot of time trying to load balance your servers. Then we have, let's say, a thumbnailing server or database servers, an indexing server, and our little Mongo cluster, because obviously Mongo can only be about 9 servers minimum. And then there's that Windows server that no one knows if it's being used, but we better keep it on just in case. And of course, we have to lovingly tend to all of them. So things can get even more complex than that. This is a diagram that a client has kindly, allowed me to use, which is basically the application that they had to prepare for disaster recovery. This is the actual application, and we had to move it over to disaster recovery. So this is a whole bunch of servers. And how do you replicate the behavior in one way on your local machine of a system this big, It's simple. We want to do this as a disaster recovery. It's a nightmare in many other ways. So this is a simple challenge that we have a multiplicity of stacks. We have various bits to our application. We might have one, if not all of the bits in our application. And we also have different environments where we're going to be deploying this stuff. So we've got like a database, maybe a queue, an analytics database, like our API endpoint, which is a server that just does the API. We might have background workers, something that's doing like, for example, doing our Verity collections, populating our Verity collections, or doing analytics, or whatever. You get the idea. And then we have to somehow deploy these in different environments. For some reason, the poll has just popped up onto my screen. So I beg your pardon. Let's just throw me that way. And then we've got like different bits of hardware that we're deploying these things onto. So we then get a kind of matrix of instructions, right? So you get a contractor that's got to work on one part. So you've got a static website that will be deployed to the development VM. Then you've got the QA server. Then you got like the single production server or the cluster. Then you've got the public cloud, whatever. So you've got different instructions that you have to do. And this is actually, if you start thinking about it, this is an analogy to a problem that's occurred in another sector. And that is the cargo transport. So before the 1960s, if you had a piano in Lima and you wanted to get that piano to New York, you had a problem. You went and got some guys to come over up to your house, grab the piano, gently move it out onto the street, put it onto a truck, and maybe build a specific box for it, and then move it to a ship and very carefully put it onto the hold of a ship, along with, let's say, a barrel of coffee, or however they store coffee. Maybe some bananas were like piled on top of it, and all of that was very manually and carefully taken over to New York, you know. And this wasn't good, because you got a piano that smelled of coffee and bananas arriving in New York. Maybe you could take some pigs over there as well and chuck them all in there. And of course, the whole transit from your house in Lima, Peru, all the way to New York, downtown New York, and into your 6th floor walk up, you had a variety of different transport methods, right? And I know I'm not doing this justice, but you can understand how complex that got. And so this was, again, a matrix from hell. How are you going to store your barrels of raw petroleum and do them on and deliver them via train, or store them, or how would you have to pick them up and load them onto ships and put them in factories and store them in factories before you use them? So this is again a matrix from hell that was actually solved by the intermodal shipping container. So this is a standard container that is loaded with virtually any goods and stays sealed until it's finally delivered on site. It can be loaded, stacked, transported efficiently over long distances, and always follows a standard, right? The first international standard was in the 1930s, but it became more modernized in the 1960s. And they also had this format called reefers, which are actually chilled containers. So you can carry your bananas at a certain temperature, but in another container you can have, let's say, your avocados at a different temperature, and they arrive in perfect shape, ready to be, to ripen on site, so to speak, or ripen en route if you can maintain the temperature. But I digress. But we can see that a container is a standard container that can be loaded with virtually any types of goods until it reaches the delivery. So that's the idea. And in between, it can be managed by somebody else, the transport companies. And this is similar to code. So if we look at like our application, we can put it inside somewhere. We're responsible for the contents, for the piano, for our code, and it's portable. And it can be manipulated in standard formats. It can be carried around, moved around in standard ways, right? And it can be run on any platform. So that's what Docker does. It eliminates the matrix from hell. So how are you going to deploy a static website to your development VM? It's a Docker image, right? Because it's only doing your static website, the web front end, and you can put all these containers together as one package. So this is my beautiful image, because this is what all developers look like. So why do developers care? Well, because you can build once. Once you've got your system working in a Docker container, you don't have to worry about how it gets deployed. It's a clean, safe, hygienic way of running your environment. You don't have to worry about missing dependencies or modifying your machine to run something. The other day, I wanted to check out something, Django library. I can't even remember what it was, and I got into this dependency hell. I started looking at what else I had to download, and then I was Googling errors, because I'm not a Django developer, right? And I'm sure someone in the audience can go, well, that was easy, you just had to twiddle the thingy. But if I can actually just go and get a Docker image and run Django and then point it to some code, and that's it, right? So I've got a window over my notes. And therefore you reduce and eliminate the concerns about the compatibility of your code, because you can manage that environment very strictly, and you can deploy that. And why should sysadmins care? Well, because they know how to configure and run these machines, and I don't have to give them a checklist of how to deploy, whether the SSL keys are here or whatever. And we're separating the duties, right? They are responsible for deploying your code in a container, and they can scale it up, and there's standard ways of doing that to test it, and you can use it in different environments in the same way. So to reiterate, Dan, the developer, yes, he has a name, worries what's inside the container, the code, the library, the package manager, etc. And Sarah, it says Oscar, the ops guy, but actually that should be Sarah. And she worries what's outside the container, right? She worries about which ports are accessible, logging, monitoring, the network config, all those kind of things, and how the life cycle of a container. So whether you start, stop, attach it to a bigger volume or on things like that, right? But they're still the same thing. We don't have two different ideas on one side, like Puppet on one side and Vagrant on the other. We are still talking about exactly the same thing. So say, well, that's a brilliant idea. Don't we have that already? We have this idea of VMs, but a VM is actually copies a whole operating system within it. So they're not very light. They're like a couple of gigs, right? But Docker containers are actually isolated. They use the server and the host, but they have like just the libraries and executable that you need, right? And each one could be different, but they share a whole bunch of the kernel essentially, right? And it means they're much faster and they start up much quicker, and you can move them around. The other nice thing about containers is that you can layer them. So you can say, hey, I am using a Alpine Unix, for example, which is a very tiny Linux distribution. And on top of that, I'm going to just have this, and then you can have another layer on top of that. And when you download it, you just have small layers of change that can be stacked. You don't really have to worry about too much of that, but it means that when you download or update, not everything needs to get re-downloaded, right? And the Docker ecosystem is basically you build an image of your stuff, right? Which defines how your system's made up using a thing called a Docker file. The Docker file will have certain basic commands. One of it will be, the initial one generally be like who's contributing it, maybe a description, and you might put a name or from, and the from defines it's, let's say, from if we're doing Ortus' solution or you're using Lucy, you say from Lucy 4. So you can say, go and get me Lucy, and now I'm going to start configuring other stuff to it. So I don't need to worry about any of the other parts, right? But once you've built that container from your Docker file, you can now put it to an image repository, whether it's a public or private one, which you can then download and run. And you can make it accessible to other people or, in fact, systems, right? So if you have a continuous integration system like Jenkins, you can say whenever there's been a change to my Docker repository, in other words, I've uploaded a new image of my system, I want you to deploy that to live, right? So instead of saying, go and get me the code, you can go and get me the application, i.e. the container. So if you make any changes, so someone's drawing on my screen. Who's that? Me? No, that's not me. Somebody else is drawing on the screen. Well done, chaps. So if you make any changes, you can actually commit those changes and submit them to the image registry. So now you have versioned applications because you say this is a new version of my application, right? So you can push that. If any of you use Git, it's the same thing, right? You're just saying, I'm pushing some more changes up to the Docker container image registry, and our host can now get that latest version or roll back if that latest version isn't good. That is all well and good, but let's have a little demo about this to actually understand what this is. Is it me drawing on the screen? Someone clear that up. All right, so the first part is a Docker engine, and this is what creates a container. So let's do hello world Docker style. So all you have to do is Docker run hello world because there's a container called hello world. So first off, it will say, well, I don't have the image called hello world, right? So what it did in the next line is go and get the image from the Docker Hub, right, which is where all of these images are stored. Not all of them, but the one by default. So it's downloaded a new image for hello world. And now it says that Docker is working. It actually downloaded a container and it runs it. Fantastic. This container only does one thing and basically echoes hello world, which is okay. Let's get a little bit. Oh, there you go. Can we not clear the annotate clear all drawings? There you go. We've cleared the annotation, Brad.
So I think it was you, Mark.
Was it?
Yeah.
Awesome. Yes, that was me. All right.
Okay, continue.
I am not annotating. Come on, clear. I don't want annotation. Clear all drawings. Not annotating. There you go. All right. So if you're trying to do a web version of the hello world, we can do something else. So we're going to do Docker. We're now going to say run, and we're going to say it's a daemon, in other words, in the background. We're going to define a port. We're going to point our port 80 to the Docker containers port 80. We're going to give it a name called web server, and then we say what we actually want to run is Nginx. So now you can see that it's downloading a couple more images. It's downloaded it, and now because I said put that -d, which is as a Docker, as a daemon, I beg your pardon. Now we have Nginx running in the background. Now you might say, well, this could mean that I could have hundreds of things running on my machine. So you can see what's running by actually doing PS, which is like process status. I mean, anyone know the PS command, right? But if you use Docker PS, it will show you, and here you can get it's not wrapped very well, but you can see that the initial line, oh, I can do annotations. Here's our container ID. Here's the image name, which is Nginx. This was the command, right? We can say when it was created, how long it's been up, and the ports that it's exposing, which is these ones, and its name. So you can then access his name nice and clear, right? So you can also see other images that you've kind of run before. So for example, you can see my mouse, right? You have the world Nginx, which is created 9 minutes ago and it's been up for a while. And this one that you can see that it's exited because it just run the function and it's gone. It's just is gone away. Of course, now that we've created it, this is done with the -a, which is switch, which equals all, right? These are the PS, it's like following the PS command on your command line, if you've ever used it. So how do you delete one of these machines, right? Remember we gave this machine the name web server, right? You can actually just go and do that by doing docker stop web server. Brilliant. So by giving it a name, we can actually now refer to it in something in more plain English. But if you remember that you had an ID, you could also say about this container ID. But this is an easier way to do it. So if you do Docker images, it will actually show you all the images that you downloaded. We had like the image is kind of like the blueprint for our application, so we can use it multiple times with different configurations, right? So let's say you want to build your own application and image, right? So let's go and do that. So this is my application. Hello from the Lucy Docker. This is my fantastic application. It does one thing and one thing very well, and that's tell you the time. Now I can create a Docker file in there. So I can do Docker, create the file called Docker file, and inside that I can put a from, which is going to be Lucy/Lucy4, and I'm going to copy the www folder into the internal folder called var www, which is where Lucy normally serves stuff from. So if we now build it, we're going to do Docker build. We're going to tag it, give it a name called My Lucy App. I'm going to build it from somewhere. So that dot is like from my own thing. So there you go. It goes and pulls all the different layers that makes this container, right? So the operating system, maybe Sun, maybe Java, some's Java, I mean, and then it might be downloading Tomcat and anything that it needed as different images. So now it's doing our build, and it's built, and you can see is successfully built a container called 04 whatever, right? Now, if we went and had a look at that, you can see, if you wondered what was in the Lucy/Lucy4 Docker file, because that's what I want to get from the Docker Hub, right? You want to get that other one. And you can see at the bottom here is the URL from that. But you can see it's a little bit more complex. But again, it's inheriting from the Tomcat 8 with JRE8. You can see the maintainer. Oh, I'm going to see if I can use this fancy schmancy thing. Where's right? So you have from, you have a maintainer, you have some environment variables. These are probably out of date now, by the way. But then you can run, right? And you go and get all these jars, delete them, and do other parts. And you can do whatever it needs to for your application to work, right? So you can do your own stuff. So once we've built that, you can do Docker images, as we did before, right? And you can see amongst all of the different images, we have the Lucy/Lucy4, which we just downloaded by being part of our app. And you can also see my Lucy app, right? So here's its image ID. This is its nice name, right? It's the latest one. And there you go, right? So you can see the size of them. Like my Lucy app is 435 megs, Lucy4 because it's an instance of the Lucy4, but without added stuff in it. So now, of course, that's great, but let's run our app. So if you now do docker run minus port, right, we're going to port 8888 to my local 8888, and I say which one, and you can see there you go. If you've ever run Lucy, you can see that, well, this is the way you run it. So if you go localhost 8888, here you go. We didn't put the -d attribute, which we've made it Docker and we've made it all silent. Okay. I am showing the official Lucy image, but yes, supports ColdFusion, etc. Okay. Yeah, I'm using Lucy because it's something that we know about. This will work for PHP, for most other programming languages. Cool. So the next part is Docker Hub. So basically, you saw that I referred to it, but basically the Docker Hub is a couple of things. There's a cloud-based registry service which allows you to link to code repositories. Think of it as GitHub, but for your containers, essentially. You can build the images there, but you can also run them because they know how to run containers, right? Containers are easy to run. So you just put them in there. And I know a lot of people don't like the command line type stuff. So one of the nice things about Docker, when you install it, you also get a program which has been in beta for ages, but called KITEMATIC, which means that you can actually go and search for software that you might want to run. So for example, I'm just having a look. If I wanted to run a Minecraft server, I could just double-click that container and create my own Minecraft server, or Solr, or Elasticsearch, or whatever. And this is a fantastic boon because I don't know how many of you have had like your boss say, "Can you guys like look into this new technology?" And what happens? You spend half the day trying to install the damn software. But in here, you can just get it running, and then you just make modifications to the config, and you can point it to a folder, etc. So now that we've created our app, we kind of want to put it into Docker Hub. So I can build and tag my app. I think there is already one. Your command box should be in KITEMATIC. So now we've built our image. So now we've got a container. I can now do Docker login, which allows me to log in, and it succeeded. And I can now push my Mark Drew, my Lucy app, right? And it'll then slowly go and push it all up. And we don't have to wait for a lot because I think I've edited this so you don't have to wait too much. But basically, it will generally know the differences of your app, and you can put it up. There it goes, pushed, and it should go there. There you go. So now you have an image in there. So now if you went to Docker Hub, for example, or you went to my account on Docker Hub anyway, you can see that my example app is there. So I can now share that, give it to other people if they want to try out, and see it in KITEMATIC. Now let's go and get my image. So I can see that there's Docker images, and I can remove an image. So if I remove my Lucy app, there you go. I've removed that one. Now I can actually run it. So Docker images. You can see that I don't have anything in there. Let's pull Mark Drew, my Lucy app. I actually have one of these pre-built images that I did, which is for Lucy with the MongoDB connector, which I use for various projects because I was using a lot of MongoDB. So I already have it built. And there you can see, I've downloaded my image ID, which is the same as my initial one, and it's all there. Now, that's great building one machine, but websites or web applications generally are not just one machine, right? They're generally a collection of machines. So you'll at the minimum have you'd have Lucy, let's say a CFML engine, and you'd have a database, right? So this is where Docker Compose comes in. It's a tool for defining multiple server Docker applications. Or multiple container Docker applications, I should say. So here is an example of and it's all done by a Docker Compose.yml file that you can put in there. So the first part says the version number of this dialect, which is 2, and then put the services. And underneath the services, you can then have also networks, for example, on the same level. And then underneath that, I've given it a name of web, and I say which image it comes from, and you saw me pushing that up. And then I say which ports I'm exposing. And that's literally all I have to do. I then do Docker Compose up, and you can see it's starting Docker Web 1. And it looks slightly different because it's got this little web _1 there. And let's go and see if it's working. And there we go. We have our web app going in there. Fantastic. So what if we wanted like a database and maybe MongoDB? So there you have it. We have on the services, we have web, and then underneath that we have Mongo. And we said the image is Mongo, and that's going to be the default install, and an image called MySQL. The interesting thing to take away from here is that web, Mongo, and MySQL at this level, time for annotate. This, and this will be the internal domain names that they can talk to each other with, right? So now if we run it, so if you now do Docker Compose up, it didn't have Mongo, so it's going to get that. Doo-ba-doo. It didn't have MySQL, so it's gone to get that. And Brad, I was just thinking that maybe whichever example you want, you can actually just put it if you're using Docker Hub. And there we go. So we've now started up our web application that has basically a database. It's got MySQL, and it's got everything else. If we want to connect to it, I don't know if you know in CFML, you can actually put your data sources as code. So basically, I put it in the application.cfc because I don't want to be doing any admin. Obviously, I keep it very, very safe by putting a blank password because no one's going to guess that. And now we can do an example. So for example, I'm going to do hello, this is the output. We're going to see if we can connect to it and get some database names from it. And again, you do the usual thing. You do a Docker build. So we've built the app. We've pushed our Lucy app because our compose file is getting the image from there. Now we can do Docker Compose up. And what we get is, we couldn't connect to it. So the reason we couldn't connect to it is because we needed to say a couple of things. And here's a couple of little tips of what we can do. So first off, we can say that my web app depends on Mongo and MySQL, right? Also, MySQL needs a password and default database to be created, and you can do that with environment variables, which you do by environments. The other part here is what I'm doing so that I don't have to keep on building everything else. It'll build a Docker file because I've said build dot. But if I put a volume, I'm now pointing this folder to this internal folder there in the container. Just asking for MySQL, did it get that remotely and the most recent version? Yes, because the tag will be the latest. You can also do a specific version by doing MySQL and a version stuff. All of it works on Windows. There's even Docker containers for Windows, which are headless versions of Windows. Microsoft is going all in into the containerization, and I think that's most of how their Azure stuff works. So now that I've done these fixes, we can have another look, and you can see that we're saying hello world is going to go and get all the information schemas, and we are winning. Awesome stuff. Now, how many people have tried to do load balancing? It's so much fun, isn't it? Cluster cats was the magic, but now, you know, we want to actually load balance our application a little bit, right? So how do we do that? Well, there's a nice HA proxy image, right? So if you've heard of HA proxy, we're going to say what we're going to do is load balance the web. We need to put a volume to keep the socket open, right? So it knows where it is. We say which ports we're going to point to it. So we're going to point 9090, and the rest remains the same. So that was it. So now we've pointed. There was no other configuration. Most of it's by default. So you can now do that. And what I'm going to do is put a little comment here so we know which server we're going for, right? So they'll have an address. So great. So now let's start that up. Docker Compose up, right? So it starts up all the different bundles, all the different services, and there we go. So you can see Web 1, etc. It's all going. Come on. Okay, cool. Nearly there. So we can see that if we go to localhost, what was it, 9090, you can see that I'm hitting one server, right? And now it's starting up again, and we have one server. But what I can do is now scale that. So I can do Docker Compose and then say the scale. And what we're going to scale is going to be the web application, and we're going to have 5. So now you can see that it's starting up Web 2, Web 3, Web 4, Web 5. This is another instance of Lucy running there. So now keep an eye out on this IP, which is what we're putting out. And it takes a little while because they're all just starting up. But you can see that each time we hit each one, it's now added it to the cluster. And there we go. We're doing round robin load balancing. Now we can resize it. Oh, you can see now we have all of these servers now running with just different ports internal. So now I can scale web back down to 2, and you'll kill off a few of those servers. So we can actually handle and orchestrate much better. So now if you see this, you're just swapping between 2 servers. Cool. So the idea, now you have this idea that you have your app and you can scale it and you can have multiple instances. The next part is Docker Swarm. Now Docker Swarm is to how you manage your clusters. So you have a description of your application. So this is your application being carried through. But now you can load balance that across various servers that you say they're part of your swarm. So you can now scale and that will orchestrate where to create the containers to where it's got different capacity. And they don't have to be in the same physical location. So for example, you can have some in DigitalOcean, some somewhere else, and you have a cluster manager that will be managing where all your stuff will start getting deployed to, right? So that's essentially Docker Swarm. There's a lot more detailed, but it's way out of scope for this presentation. And of course, you can't have anything that's containerized without having the word cloud in it. So Docker Cloud is a hosted service that provides both the registry, which is what you've seen, the hub, and testing facilities for different images. So you could, on the moment that you push an image up, you can have things happen. So you can say, go and test that it does its own thing, that it runs, that has tags, etc. So you can have the health of your container, monitored by Docker Cloud. For example, you can see all of my different containers that I created, and they're all there, and I can just create instances of them. I can run them. I can see how well they're running. I can see whether it should auto-deploy the new version, and it handles all of that. There are many other orchestration systems. This is Docker's own, but of course you might have heard of Kubernetes. There's also Rancher and various different orchestration systems that allow you to either deploy or to manage stuff. You can also do like team management, so people get notified, and developers are going to be doing things in there. Some questions from the thing. So orchestration is not a thing that's inherent in Docker, but the whole point about Docker being little boxes means that, and the same way that you manage them means that you can create orchestration services as many people are doing, right? And this is what Docker Cloud is for, and what Rancher, and there's a whole bunch of other ones which I'm failing to remember. So it's been so since it started in March 2013, these stats are probably way out because I need to update them. It had 100,000, 200,000 pulls, lots of stars in GitHub, and it's been used everywhere. And in fact, I think most people are now turning this, throwing away their vagrant ideas, giving Docker configs to people, and it's a much easier and lighter way to do it. There's thousands of Dockerized applications. I said Lucy's one, command box is the other. That then means that you can have ColdFusion or whatever. And of course, systems like Jenkins, and if any of you have used Jenkins, you can actually do a lot of stuff with that. So you download your image, a container, and you can run tests against it and then deploy that, and Jenkins knows all about this. So if you want to learn more, you can go to docker.io, obviously. There's loads of documentation in there. There's very specific documentation about the Docker file and the Docker Compose file, and you've got tutorials, etc., etc. And there's loads of information there. You can go to a meetup and learn even lots more, or you could be doing this roadshow for the next 5 Fridays. You'll be learning loads and loads more. I'm at Mark Drew on Twitter, so if you have any questions, you can throw them on there or throw them into the group chat, or tweet at Docker. Other questions. There's a lot of questions about Windows. With Docker, you start something. Docker Swarm is an example of where you create a service and say, "Yep, that's right, that's right." Does Docker support running on WSL rather than requiring VirtualBox? I think so. Just check the latest version of. There are lots more images running on Windows that are Windows specific that will run fine on Windows. But anyway, thank you. My name is Mark Drew. You can take a picture of that if you want to follow me on the Twitter. And yeah, thank you very much. I'm trying to stop the share. Where's the share?
Awesome. We can just handle questions for a few minutes if you like.
Yeah, sure. I just can't find my mouse to move the chat. So.
Do you want me, should we stop the recording or should we record the questions?
Yeah, record the questions. Why not?
Yeah.
It's knowledge.
I'll activate a couple polls as well that may pop up. We're still figuring out how that works.
All right. John Wish. Yeah, one of the things that I showed is that you put a -v or you put a volume. You can attach a local hard drive volume. So if you're doing development, you can have like your ColdFusion server in a Docker container that's looking at your local volume, right? So you can do it for development, so you're not having to rebuild an image every time. Eric Peterson. And generally what you want to do is you can either have an external service, but generally I try to wrap up the whole application because then you don't have to have any compilation. You could create a Docker container that's already pre-warmed in the sense that you've built up all your cache or you've built up all your compilation by doing, you know, CF compile or whatever, however you do it, like pre-warm it, and then you do a build. And that can be, again, automated because what you can have is, for example, you can have a Docker container that is your general automated build, and then have Jenkins download the container, warm it all up, and then retag it and resubmit it as your warmed up after it's run the tests. How did I auto-connect the MySQL without using Lucy admin? I used in the application.cfc, you can actually put in all the details about that. If you use Lucy and you go into the administrator and create a data source, at the bottom you actually have like the code that you can put into your application.cfc. So you can either copy that and put it right in. So therefore you can then go and delete it from the admin and no worry about the admin anymore. So what I tend to do is have a lockdown version of the admin and stuff that doesn't even allow you to go to the admin. Or you could use something like cfconfig, which is another project by these lovely Ortus guys, to define a file saying this is my configuration, put it into my container.
There's also a safe mode in the command box image that if you activate it, it'll remove access to the admins as well.
Okay, great.
Just an environment variable.
I haven't caught up with all those bits. The system requirements for Docker on Windows are misleading. It installs fine on Windows 8, 10. It's just not officially supported. Yeah. The thing is the thing about Windows is like, are you using Windows for hosting or for just coding? I mean, yeah, I don't want to get into this Windows
battle,
but it's usually like there's no particular benefit for running stuff on Windows in a server-based environment as a container. Unless you have something that's very specifically kind of, you know, Windows-based.
Do you have any ideas for better ways to sync the volumes? There's some issues with performance sometimes with different providers and whatnot. We notice if we're having a really intensive app, it can kind of go a little crazy. So there's online stuff for like syncing and doing all sorts of other stuff. But have you dealt with any of that?
What I tried to do is just put it into the container, so I'm not doing volumes on it. Now, when you have to do volumes, I guess it would be was MySQL or something like that, or are you talking about code?
Well, just code when you're in your developer box, you know, and you'll just.
Well, the things I haven't come across those issues, so I haven't tried to fix them.
Okay, just thanks.
Any other questions? Cool. Take care, Jim. See you at NC DevCon. Yeah, I'll be at NC DevCon, by the way, but I'll be talking about something else. Cool.
All right.
Well, thank you, everyone. What would someone use Windows over Linux? I have no idea. Not for hosting. I mean, Windows. I use Windows, OS X, and Linux, and I use them in the right place.
All right, folks. Well, Mark, thank you so much for your time. Great
You're welcome.
kickoff for the Roadshow. So a whole month of great stuff coming along. First time we used Zoom, so thankfully everything went okay, except the mysterious annotations, which was actually Mark.
Yeah, sorry about that. Well, I was busy. I was trying to present. Just a bit of advice: just end the meeting, and it should download the thing.